Hi everyone, and welcome to this final event in the Microfiber Innovation Series by Techstyler and Conservation X Labs. I'm Brooke Roberts-Islam. I'm the founder of Techstyler and senior contributor at Forbes, and I'm delighted to introduce the panelists for today's textile microfiber pollution discussion. First of all, I'd like to introduce Sydney Gladman, who is the Chief Scientific Officer at the Material Innovation Institute. I'd also like to introduce Kyle Blakely, who is the VP of Materials and Manufacturing at Under Armour, and Neil Dunn, who's the CEO of Polymateria. Welcome, everyone, and thank you for joining us today for this discussion. I'd like to kick off by just giving a short introduction to the Microfiber Innovation Challenge, which is being run by Conservation X Labs. It's the reason we're all here today, and it's the basis of the discussion we're having. Microfiber pollution is a growing problem in the environment, and it's a huge challenge to tackle, both in terms of material science, but also in terms of pollution management. The panelists today have a wide range of expertise in this area, ranging from scientific research through to brand and product development. So we're going to have a debate about some of the potential challenges, opportunities, and limitations of solutions to the microfiber shedding problem in textiles. So let me kick off first with Sydney. Sydney, you've done an immense amount of research into this area, and I know that for the past 5 years you actually focused on synthetic polymer material science. So tell us, to your mind, what are the key challenges and opportunities in terms of tackling microfiber shedding from textiles?
Absolutely. Thank you so much for having me today. I spent 5 years consulting in the plastics industry before my role at the Material Innovation Initiative, which is a nonprofit focused on sustainable material innovation. And what I've observed over the years is that there's been growing obvious concern over microfiber pollution in the environment, but governments generally are taking a little bit of a wait and see approach, a little bit of, well, we don't know what it's going to do. We don't know if it's an actual problem. And especially in places like the United States where I am, really legislation will not get passed unless there is enough reason for it to happen. I personally, and I think many people in this panel and participants in this challenge think we shouldn't be waiting and seeing what will happen. We should prevent this microfiber pollution from occurring. And fortunately, it looks like some of government bodies are starting to turn around and understand that this is an issue. In particular, the European Chemicals Agency, ESDHA, is working on a microplastics legislation. In particular, they are only right now drafting it such that intentionally added and released microplastic particles will be part of the legislation. But if you read some of the language, you could, start to see that down the line, this will alter and change and start incorporating textile microfibers into the equation. In particular, I'm just going to read some language that they would potentially be banning the sale of microplastics on their own or in mixtures where their use will inevitably result in releases of microplastics to the environment, irrespective of the conditions of use. So right now, that's focusing on things like personal care products that might have, microbeads and other things in them. That's the big target. But if you read that, textiles right now do kind of inevitably result in the release of microplastics as far as we understand, as synthetic textiles are concerned. So you could interpret this to kind of apply to the textile space as well. In the United States, for example, California and other states have also started to take some traction to move against microfiber pollution issues with things like mandatory labeling of synthetic textile garments that would, indicate this is a microfiber shedding material. And consumers would have to make the decision whether they want to purchase that product with that label. So there's a lot going on in this space that is really, I think, going to start turning the tide. And we'll see, what happens. But there's a lot of pending legislation in this space. As far as our broad solutions to this problem, the microfiber, innovation challenge is going to, I think, be a huge step in the correct direction. We've already seen a lot of interesting plays in solutions in this space, and there is a ton of opportunity, right? Right now, material innovation investment is, at an all-time high. And I think that is going to be one of the best places for us to start is, that's going to be the longer term solution, but I think it will be the more permanent solution. So finding alternatives to our current synthetic plastic materials, thermoplastic materials that we're using in our textiles that are biodegradable and hopefully also bio-based from their feedstock is going to make a huge impact. In addition, there's a lot of work right now, as you mentioned, Brooke, on kind of more process control, right? Laundering is one of the big places where we're seeing the shedding to occur in textiles. So, solutions that focus on, home and commercial laundering solutions that will collect and prevent, microplastics from shedding from textiles into the waterways.
Further downstream, yeah. I think one of the key aspects, from conversations I've had with you, but also with Neil and with Kyle, is that the fundamental chemistry behind the synthetic materials we're using poses challenges. The performance is great, the characteristics are great in many ways, but the trade-off is huge. Neil, I'd like to come to you now to talk a little bit about crystallization and how those characteristics determine the shedding of the ultimate textile. And if you could also relay to us what you've learned at Polymateria through creating single-use packaging with a layer that allows protection until biodegradation and biotransformation is required.
Yeah, thanks, Brooke. So we were built from the ground up about 6 years ago to be a mission-driven company, and I know that's probably to most people attending here, something we all kind of buy into. But in trying to understand the problem, what was really interesting is firstly, 32% of all plastic winds up in the natural environment. And plastic is a very broad, Kyle will know this from his role, that the materials involved are as wide and varied as you can possibly imagine. There's such a huge difference between polystyrene and PVC and the toxicity there versus polyolefins, which are a very pure material. And when we actually drilled into the 32% number, what we found is that 31% of plastic that winds up in nature is polyolefins, so polypropylene and polyethylene. So in terms of being mission driven, we focused there and commercialized there first. But one of the biggest barriers that we came across in the first years that we were set up here in Imperial College was no one else had figured out how to attack and destroy the hard crystalline structure of the plastic. If you don't do that, you create microplastic. You might be effective in the amorphous or the nebulous regions, but you leave the crystallinity intact. So for non-technical people following, that's almost as bad. It's you take plastic and you fracture it and you break it. It becomes almost invisible to the human eye, but you still have a polymer at the end of the day. You haven't fundamentally changed it. So what we had to set about doing is basically understanding the crystallinity for polyolefins in a kind of a deep and profound way, and figuring out how do you actually attack and destroy it. Now, what that should give you, if you're being effective, is a grease or a wax-like material. So in chemical terms, you're down into degraded oligomeric type material, so kind of C8, C10 type territory. But you also have to make that grease or wax attractive to nature. And then interestingly, the stewardship aspect of making sure you're focusing only on pure materials, which will be one of the founding principles of the circular economy, is that we should design for everything to go back to nature sooner or later anyway. So design with, this kind of concept in mind, but give the kind of the human-made technical cycle recycling every chance to happen. And the way we kind of came up with for catering to that was a time-controlled aspect. So timing exactly when the materials would become active and begin the process of return to nature. So that's kind of what we've done for food packaging. And, we're very aware that a lot of the things that we've kind of learned, both in attacking and destroying the crystallinity, but also in the time controlled aspects, could be very relevant to other industries and other sectors.
Mm. And this is where it does get interesting, is the idea of potentially applying these technologies in an industry where, in effect, a whole segment of product, which is often termed fast fashion, is sort of analogous to single-use plastics in some ways, to be blunt about it. Kyle, I'd love to hear your insights next, actually, on the consumer expectation side of things, because what Neil's done is describe the science behind polymers and managing them, augmenting them, changing them to behave in a certain way. But at Under Armour, you're sort of shackled with the expectation, or not shackled, but you operate within the expectations of your customers. How does that impact the way that you focus on polymer science? Because I know you have a lab. I know you're doing this on the ground.
Yeah, I appreciate it. First of all, thanks for having me, and thanks for everybody joining today. I guess the first thing is to acknowledge that this is a problem. You know, you can debate whether microplastics have an effect or not, but they're in a place they shouldn't be. We need to acknowledge that, and we shouldn't do it. Secondly, aside from consumer expectation, that's also not a reason not to try to fix this. It's just a challenge that we have to hit a sweet spot. We can't change all of our textiles to prevent microfiber shedding, but to make them unaffordable or undesirable. You know, when you're looking at microfiber shedding, so much of what you sacrifice when you move away from that is softness. The consumer wants softer fabric. So instead of just throwing up our hands and saying, you know, we're stuck with this, we're going to invest in overcoming that. One of the ways that Under Armour is looking at this is really looking down the chain, looking at polymer development, looking at fiber development, and looking at the ingredients and the inputs in the textiles to see how we can create these inputs to prevent microfiber shedding, but maintain or even enhance the features that the consumers want while making it affordable. And that's a sweet spot. It's not easy, but it's a path that we're going to go down because we have to listen to all sides of this. And so what we talk about, what our philosophy is with this problem is, we call it turn off the tap. And that's something coined by a teammate here at Under Armour who's very passionate. We all are. And what that means is if your sink is on and it's flooding your house, you don't go get more buckets and try to empty them out of the house. You actually just turn the sink off to prevent the flood. And that's what Under Armour's strategy is. So where we can, we're changing our textiles, changing our inputs to prevent microfiber in the first place. And that takes all of these things I was talking about earlier about that upfront research to make sure that when we change these textiles to prevent microfiber shedding, some ways are obvious, using continuous filaments, other ways not so obvious, augmenting staple lengths, that sort of thing. You know, we have to maintain the consumer expectation, and we're doing that, and we're taking a leap. Some of it's risky, but we have to. So I think the first step is acknowledging the problem, committing to having a solution, but also doing it. And it might not be perfect. We talk about perfection being the enemy of innovation at Under Armour. It might not be perfect, but we have to start. We're going to have a much bigger issue than we can deal with down the road. So we've already started. We don't really talk about it. And that's good because the consumers are still happy with the product. That means we're being successful. So that's really our philosophy. And our other philosophy is really, you mentioned our labs, you know, helping standardize and quantify these issues. We've actually created a microfiber filter to go onto our washers in our lab that captures microfibers that we know are getting into the water stream, at least in what we can control. We've created test methods for microfiber shedding. I want everybody to know that, yes, apparel does shed microfibers, and yes, you can measure that. And so we've created methods to start using to make the textiles that we have tested on these that are clearly a problem that we choose not to use now, that we wouldn't have even had the perception before. And frankly, some of the reasons fabric shed are surprising. And so we've had great insights there, and we're already making decisions. We want to share those things, get other people's inputs, and scale these things out. So I think Under Armour's primary strategy here is action. Hopefully it's right, but if not, we'll partner with people like you, and we'll continue to build and grow and evolve. But our strategy is to do something that we know is positive and start changing our product.
Well, it's interesting that you've brought an aspect of the R&D and the pre-textile phase in-house, and that you're running your own lab. And I know that you have accompanying equipment so that you can actually develop textiles and test those textiles in-house. So I think that in itself demonstrates a sort of level of dedication and desire to know what's going on with your textiles. I'd like to come back to Sydney, because Sydney, in your role at the Material Innovation Initiative, you're doing in-depth research into potential replacements for incumbent materials. Is there anything you've discovered through your research on microfibers and potential bio-based replacements that could be a catalyst for a new material or emerging materials?
Unmute. Yes, absolutely. There's really a lot of exciting things happening right now in the innovation space that we're tracking. Some of it is actually quite interesting. We're seeing kind of parallels and learnings from other industries now getting applied to the textile industry. So, starting, packaging being a really good example, which was kind of one of the first hot targets for, let's say, the pollution of plastics. People kind of went straight to packaging. But also some industries you wouldn't expect, like food, the alternative protein space, for example. People are pretty familiar with things like Beyond Meat and Impossible Burger. These things really got off the ground recently and are relying on relatively deep tech innovation, things like precision fermentation that is creating novel molecules, right? And we're seeing that with bioplastics, right? We're seeing people use bacteria or yeast as factories to create novel biodegradable chemistries that are thermoplastics, right? That could come in and potentially replace polyesters, nylons, and other materials in this space. And it is going to be a little ways before those are going to be at price parity or at volumes at which the industry can use them. But that doesn't mean we shouldn't be excited about them and be investing in them now. They're, like I said, more long-term solution. We're also seeing a lot of innovation in somewhat, let's say, alternatives to synthetics. They're still synthetics, but they're their own version. The cellulosic space is getting quite hot with ways of creating more sustainable and higher performing cellulosic materials that might start to come in maybe as blends or as 100% replacements for some of the synthetic fibers on the market. So that's some of the things we're excited about. But I think right now the strategies that people like Polymateria are taking with, let's take existing materials that are already working and make them better in their downstream end of life, that's the solution that we should be tackling right now. And then we should have this multifaceted approach of let's start from the beginning of life as well, coming in with new feedstock that has new properties that might outperform, our incumbent, synthetics. So that's what we're excited about.
Neil, following on from that and sort of linking up with what you were mentioning earlier, in what ways, if any, could your technology and your development at Polymateria be applied to other forms of plastic, like filaments, extruded yarns for textiles?
Yeah, so just coming back to being, mission driven as a business, we went after the fossil-based materials first, because that's where the problem is biggest, to Sydney's point. But we also have proven the technology with bio-based feedstock as well. So it's more a case of where is the problem biggest, and also where is there a market? Because at the moment we cannot get anybody to pay for the bio-based stuff that we're able to do, but we can get a lot of commercial traction on the on the fossil-based materials. So I think just in terms of the kind of applicability to other materials, we just announced last month a global partnership with Under Armour Ventures for non-wovens, which brought a lot of our the lessons that we learned in kind of food packaging into the culmination of an 18-month collaboration with them to figure out how we can bring the technology into PPE. Masks, also wipes for personal care and for hygiene. And I think that's where, from an apparel perspective, it starts to get quite exciting, because non-wovens as a material and potential candidate for biodegradation, could be a very interesting area to explore with the right apparel brand. Because we certainly don't have all the answers in terms of material performance and characteristics, but we certainly have with Under Armour in particular, supporting scale on our side. And just to maybe come back to what Sydney was saying around some fermentation technologies, we're similarly excited about, a lot of those and watching that space very, very carefully. But mostly what we're seeing is even the biggest guys can only produce about 5,000 tons per annum. And this is a 100 million ton per annum problem. So, we just need to remind ourselves of the fact that that's kind of what we're up against, which is, why we're pointed in the direction we are.
Yeah. So again, as it is inevitable with this kind of discussion, it comes back to scale and volume and then price. So Kyle, maybe talk us through that, because I know that you've been enthusiastically researching a whole range of material options as alternatives to less sustainable ones in widespread use. What are the limitations from a brand perspective on that front?
Well, certainly some of the near-term limitations are capacity and availability, because there are a lot of companies out here striving to make improvements here, and there's a long line to get these materials to get them scaled. So that's certainly a factor, not a terrible problem to have in the sense that it means people are doing something. But the other piece is, again, going back to consumer expectation. I think if you look at some of the cellulosic options that are coming online, which are beautiful and make sense, they're significantly more expensive. So, and then you get into the cart before the horse discussion. Well, you need economies of scale to get that cost down, which is going to come first. And we have to find a sweet spot. And so, we do spend more on some of these materials and don't pass that to the consumer, to be frank. Some places we do, but that's really when we start thinking about how we create more sustainable materials that also do something else, that drive a higher level of performance. Very common one that we have in market now is something like solution dyeing, where effectively waterless dyeing, but higher performance because the color has better color fastness. So you could justify sharing some of that cost with the consumer because it is making a better product, and that's an important strategy for us. And so we're hungry for those types of things for sure. And then some of these new inputs that are being discussed on the phone call, you got to start somewhere. And so I think it's important for brands to look at where that makes sense and just start somewhere and let it grow, seed scale, maximize. And certainly that's what we're looking to do. I think flipping some companies' largest programs is super disruptive, and I'll just continue saying it. That's not a reason not to do something. So we're strategically looking at areas where we can afford to use some of these new fibers and just get them out there and get them to scale, and then see where it goes. So. Again, I know I keep repeating this, is the strategy is to do something, not nothing. Mm-hmm. And so, yeah, we're looking at all these things. And I think part of it too comes from the partners that are making these ingredients to really help with communicating to the consumer what those benefits are besides them just being sustainable, because they do have other benefits. And I think that's a major opportunity for the industry to talk about those things as well.
And actually, does the success of introducing new, more high-performing, more sustainable materials hinge on having the right kind of product categories and product profiles out there in order to place these materials? Because where I'm going with this question is my mind sort of goes to fast fashion again, and sort of disposable fashion, which has an inherent problem that it overperforms for what it needs to do. And there's not a lot of scope to build in either a higher price or more performance. But with a sportswear brand, or let's say an outerwear brand, it seems on the surface that you may have more scope for that. Are you working towards certain product types that will have more sustainable materials embedded in them? Is that how the strategy works?
Yeah, there's a multitude of strategies. We want to affect the highest volume possible. Because we want to make the biggest difference possible. So obviously that's a factor. It's our perception that, agnostic of sport, athletes have this expectation of brands. So it is hard to look at it on a sport basis. But what our athletes do expect is performance. And so it really is finding the sweet spots where we can do both and provide that specific performance to that athletic category. And we're doing that. We have a significant amount of programs right now where we've looked at microfiber shedding, 100% recyclable stretch is an example, that we've had good success and that actually provide legitimate performance for categories such as run. So it can be symbiotic and it can work together. But again, you know, it's an expectation of our consumer agnostic of the sport they're playing.
We're going to be moving towards questions related more to legislation and regulation. And before I come to Sydney, I just want to ask you, Kyle, your views on that. And you know, there's a lot of discussion going on, but not too much set in stone in terms of imposing limits on companies or imposing fines or carbon taxes. Where do you sit on that at all, if that's within your remit at Under Armour?
Well, from a regulation standpoint, the biggest thing is to, you know, we'd like to have a seat at the table because there's two sides to everything. And you know, hopefully we're displaying there's no lack of desire to move this forward. It just needs to be on the right, responsible timeline. And so, you know, that's our position, is to be able to articulate challenges on both sides. And we have empathy for both sides. And it's really not two sides. It's just one side figuring out the right way to make this work for both industry and consumer. And that's where we want to participate.
And in fact, it's been challenging, you described during our preparation call, because there aren't any universal standards really for assessing and limiting microfiber shedding. So you've set your own internal targets based on best practice and external expertise. Maybe talk us through that a little bit before we come to Sydney, in terms of what you've put in place and how you're intending to share that.
Yeah, I mean, to be clear, there are standards emerging that work for some industries better than others. You know, we have a very special lab here. We call it the Proving Grounds, where we're able to engineer test methods that are fine-tuned to our product type, that we are looking at how they affect other product type. But, you know, we have created a test method shedding protocol that enables us to, you know, get a read on our textiles. Of course, we're still in major data collection mode to know where to draw the lines, right? It's very early. You need a lot of data to figure that out. But,
yeah,
you know, we've created that method mainly to make sure we don't do something silly. And if we get a textile on that method that is clearly shedding a lot based on the benchmarks we do have, we won't use it. And so I think that's the best first step. Long-term, understanding what those universal ratings are, how that affects GB China as an example. You know, we all need to get together on that. And what I can tell you is Under Armour is willing to share what we're doing, get feedback, you know, and two things: really work to make sure that what we're doing works for our industry and others potentially, but also make sure we're creating instrumentation that's scalable, that people can afford. So not only this can get into brands, but also get into global mill partners. You know, creating super expensive instrumentation to solve this problem is not going to work. It needs to be something scalable and something that makes sense for multiple industries. And Neil, I think you wanted to jump in. Sorry if I talked too long.
Not at all. Just on standards, Kyle. Just to support what you were saying, I think this is an area that we all can, you know, collaborate. And you mentioned at the start how, you know, you'd be happy to see the competition on the call with you here today, and I feel very much the same. A lot of the standards that, you know, are being used out there are 20, 21 years old, and that's why. Sorry, for biodegradation specifically, and science and innovation has moved on considerably, as Sydney will know, in the last 2 or 3 years in particular. You know, there's a lot of new evidence emerging. I think one of the things people sometimes confuse is the difference between a test method, you know, which you know, with ASTM, Kyle, you'd be familiar, is kind of used a lot to kind of almost create a greenwash, where just because you've used a particular test method doesn't mean necessarily you've reached a rigorous pass-fail criteria. That if we're all to be testing and ensuring that we're not creating microplastic or microfibers, scientifically we should be clear on what those pass-fail criteria are. And that was why we made the decision to open source part of our IP and create a new standard with the British Standards Institution to show that that polymer is no longer acting like a microplastic or a nanoplastic, that it now unequivocally is behaving like a grease or a wax. And there's about 4 different pass-fail criteria in place that you have to achieve in order to prove that. So these are the types of things that we should, all be leaning into, all sharing our data, using peer-reviewed evidence as much as possible to kind of inform the debate. And we're happy to work with our own competitors to achieve that.
Mm. And Sydney as well, I think it would be useful to have your input alongside of Neil and Kyle, because you were talking to me about your research into sedimentation in water and levels of microplastics and microfibers that were being detected in the last 5 years, and so being able to distinguish between those and attribute certain levels to certain industries, and in this case, textiles. Can you talk us through that a little bit so we can understand the magnitude of the problem and how these standards might be applied?
Sure. Yeah, in the research space, I mean, it's relatively new and we're still learning every day. What is the microplastics problem and who could it be attributed to? But recent studies have shown that if you just characterize the microplastic particles that you collect from the ocean by shape, you'll see that the second most common shape is a fiber, right? And that just will automatically going to get attributed to the textile space, because that is primarily where we're going to see fiber-based particles take hold. And so that's where a lot of the numbers come out for how much textiles industry is contributing to the microplastic problem. One issue there is that we do think it's probably underestimating the issue, because these the collection pathways that people are using are surface skimming methods, not going down to the sediment, where a lot of our fibers, which are denser than water, are going to fall. Things like polyester and nylon are going to be down at the bottom. So we are seeing more things like polyolefins at the top, because they could still be floating or near the surface. So that's just to say that the problem is still being understood, but not to say that we shouldn't still be trying to prevent the problem entirely. And hopefully we don't even ever have to understand the complete complexity of the issue. Mm-hmm. But, just to tie on to what Kyle and I were saying, I agree that, standards and test methods are completely different and mean different things, but I think we need both, right? In order to implement a standard, you need a test method by which to quantify levels. And from what I've seen, just generally in the kind of history of, I'm going to call it hazardous chemical regulation, even though I don't know we apply microplastics in that category yet. But it's going to be a slow implementation, right? It's going to start with some, threshold level at which you should not be releasing, and it's going to slowly work down. And that's going to allow for a lot of the innovation to catch up, right? So those initial limits are going to be placed on things that have really high numbers. Like right now, I'm just going to say fleeces tend to have, in a lot of studies, the highest shedding numbers. Maybe those are going to be more, tight, stringent controls on, checking their shedding, quantification. But it's slowly just going to phase out to the point where, hopefully decades from now, we now have like very minimal shedding and very minimal synthetics coming off of our textiles. So hopefully it'll be able to work together. Fortunately, the fact that standards and regulations are so slow enables us to kind of catch up from the actual implementation side. So there's actually a benefit to that in some ways.
Sure. And sort of thinking more now on the solution side of things and the potential for bio-based solutions to replace a quantity of some of the synthetics that we're using at the moment. What do you see as the main limitations? Because in conversations I've had with Kyle and also with Neil to a degree, synthetics that we use at the moment perform brilliantly. They're very, very cheap. They're very light. They have brilliant characteristics in many ways. And we just simply can't replicate that in existing fabrics. You mentioned earlier synthetic biology. Can you give us a little bit more color on that topic and share any examples that you may have seen where natural fibers or materials might be making some headway on synthetics?
Yeah, absolutely. So I would say, there's quite a lot going on in this space. One that is particularly interesting to me as a material scientist and somebody who's dabbled in biomimicry and bio-based design is that we've looked at, protein-based fibers are actually kind of an interesting subset of the space. They were, formerly and currently kind of reserved for luxury materials because they're expensive, because they're derived from animals right now for the most part. And that's part of MII's mission, is that we want to eliminate the use of animals in making materials. So we're seeing people use, for example, the same synthetic biology approaches to create spider silk. Spider silk, for those who aren't aware, is one of the strongest, toughest materials on our planet. And so if we could actually create this material in high enough quantities in yarns, we could be having t-shirts made out of spider silk that are going to be higher performing, and particularly in strength and toughness, to our synthetics. So that's one exciting arena. But that's really, it's a ways out, and getting to price parity, like Niall mentioned, and volumes is still the huge challenge there. I'm particularly also excited, and I think is a shorter term, pathway, is things like PHAs, polyhydroxyalkanoates. These are biodegradable, bio-based polymers that can be produced by plant-based kind of feedstocks in a fermentation process as well. But the nice thing about them is, unlike the protein fibers that you have to spin with wet spinning methods and kind of, totally different approaches than synthetics, this is still a thermoplastic material that can be processed with sort of drop-in kind of solution. So I see that as being a really nice pathway. However, there's still a lot of work to be done on the R&D side to get those materials up to snuff, and again, up to volume and up to cost and all that. And we did see a little bit of a bust and boom of the bioplastics space, 10 years ago. I'm hopeful now that everybody's ready to see bioplastics come to market, and with enough investment and continued innovation, we're going to get there. So that's what I'm excited about.
And Neil, you spoke a little bit earlier about plant-based feedstocks for your polyolefins, and the price consequence of that. Maybe talk us through that in a bit more detail if you can, and also if you could talk to us a bit more about biodegradability, because this is also an area that's immensely confusing, particularly for consumers, because anything can be branded as biodegradable right now and nobody really knows what that means. So if you could flesh those out for us, that would be great.
Sure, thanks, Brooke. So just a couple of points, and to pick up on Sydney's just talking about PHAs as well. So just again, for people who may be kind of struggling with some of the terminology here, the trade-off you have to make is between perishability and persistence. So what Kyle will want in his supply chain and with his customers in mind is something that performs the same. So you need to achieve a degree of stability and function and performance in those materials. And with that comes a trade-off, because by giving Kyle what he needs in terms of those requirements, you then create something that's going to be persistent. And honestly, it doesn't matter if it's bio-based, if it's what type of carbon source it's coming from. If it's coming from dead dinosaurs, or if it's coming from cassava or canola or anything else. As soon as you create that very high molecular weight in those materials to give Kyle what he wants and give consumers what they want, you're then creating something that's going to be persistent. So that's the challenging piece. And that's why we had to kind of engineer this kind of time control piece, so that you give the consumer and give Kyle what he wants for a period of time. But then once they're basically a combination of catalysts and co-catalysts that act sacrificially for a period of time, once that wears off, then there's nothing happening, the destruction of the crystallinity, the full return to nature. So that's the kind of the novel bit, and was our answer to how we overcome what Sydney is saying there. I think the big thing that bio-based materials have in their favor is narrative. It sounds great, that it comes from out there as opposed to dead dinosaurs. But, when you start adding up, 300 plus million tons of production in any given year, the LCA is horrendous, so I kind of feel like, having been in sustainability all my life, you've seen this movie before so many times with biofuels and diesel engines and other things that had these unattended consequences associated with them. And I think we have to be honest about, the difference between real leapfrog, real game changing, and something that is just a bit better, but maybe not where we need to get to.
And this is where it does become difficult, because in the short term, we have an urgent need to cut emissions and to hit greenhouse gas target reductions. And so a leap forward in renewable feedstocks, for example, might be great in the short term, but then in the long term, the trade-offs with microfiber plastic shedding, all these sorts of other things that come into play, on balance, it's not a whole solution that it's sometimes made out to be. Kyle, how do you feel about this subject? I mean, you're in a brand, so marketing plays a role in how you present and sell your products, and there must be a sort of an attractiveness to some incremental improvements, but then how do you handle the fact that it's not a total solution?
Yeah, well, I mean, certainly everything that's been mentioned, we have our finger on the pulse of those things and are watching them very closely. In some low risk areas, it's possible, like I mentioned earlier, to start, implementing those things and starting to learn what some of the downside might be, if there are any. I don't think we're going to learn without doing some of these things. So, we're taking some opportunities there, as we discussed earlier. But the main thing is really partnering with external partners, such as the people on this call, learning, understanding, looking at LCAs, and finding a sweet spot on what we could try. Even if it doesn't go to market, we're willing to try things and see what happens. From a biodegradability standpoint, our chief concern has been discussed, is that we don't biodegrade into smaller plastics. That's not good. That's kind of a pseudo comforting thing. So, I think there's a lot of work to be done in that field as it relates to our space, like Neil mentioned about making durable product. So biodegradability certainly is a challenge for now, to make sure that we make that durable product and make sure it doesn't degrade into smaller plastics. The other piece is, we want our product to last, because it takes a lot of energy to make product. And so it's really threading the needle on the life cycle of that garment and when it can go away versus sustaining is something that we have to figure out. And then on bio-based, obviously that is really important, obviously sensitive to the land use piece, but where the data is there and it makes sense, certainly we're considering those things.
Mm-hmm. I think we're almost up to Q&A time, actually. We've just got a few minutes left. So I'd like to give the panelists an opportunity at this point to just maybe state what they think is the most promising either innovation or technology or advancement in recent times that might chip away significantly at the microfiber shedding problem. Maybe we can start with you, Sydney.
Sure. It's a tough question. My easy answer to this is I'm excited about all of them. So, that's the cop-out answer, I guess. But, again, in the name of our institution, material innovation is what I think is going to be interesting. We've been using the same materials for quite a long time, and they've done a really good job. But now we've been faced with these unintended consequences, right? Things like microfiber pollution. And I think it's time for us to keep coming up with new materials. It's ready for, industry 4.0, 5.0, whatever number we're on right now. I think that's where it's going to be, is the raw material solutions are going to be the most exciting. And I can't pick which one's going to be the winner, because I don't think there will be one individual winner. Just like we have a material mix in all of our textiles right now, I think that will continue to exist, because you're going to want, different comfort, aesthetics, performance, cost profiles throughout this industry. So I think we need multifaceted solutions, lots of different solutions in the space. So that's my takeaway.
Neil?
Yeah, I think the fact that there's no silver bullet is painfully aware to anybody who's legitimately trying to solve this problem. But I think collaboration that creates much better standards is certainly something that we all need to put our agendas and sometimes our egos aside and put our data out there to show what we're actually what we're able to evidence and what we're able to prove. So for me, the thing I'm probably most excited about that I think has relevance to the textiles industry is the creation of the new British standard. The reason I think that's so exciting and relevant is the degree of polymer science and chemistry and understanding of what's the difference between a plastic, a polymer, and a grease or a wax, and how scientifically do you evidence that. For me, I think that's, that is game changing. Everybody, is going to need to have that kind of science-based approach to understanding the difference between when are you not a microfiber, when are you something that actually is capable of return to nature, or when are you something that is going to persist and bioaccumulate and create, significant ecotox issues within the natural environment. So I think, our approach to this is to collaborate, is to create better standards, and then to try and make that accessible to consumers. I think the other kind of beachhead here in all of this is Generation Y and Generation Z feeling empowered and inspired. And I think for there, we should look to the plant-based guys. I think the plant-based guys are doing an incredible job of mobilizing younger people with simple, sexy, compelling messages. And frankly, nobody in the textile space or in the food packaging space is doing that yet with their innovation. And I think as soon as we do, we'll start to create that groundswell of pressure on the system. And Kyle's business case will start to make a lot more sense, because he'll be seeing that he has to do this to win with these younger consumers.
Yes, that sort of that competitive aspect of not wanting to be left behind, or being seen as a brand that's kind of trailing behind the others, and therefore being more polluting. Kyle.
Yeah, just to add real quick, because I think, the aggregation of all these opportunities is obviously the most exciting. As everybody said, there's not a silver bullet. So I'll say this, and I hope it's not cheesy, but what I'm most excited about is the universal willingness to give us some space to solve this problem. And what I mean by that is there are known construction methods in textiles. There are known yarn formations in textiles. There are known polymers in textiles that help us address this problem now today, that we can scale now today. And I feel like the consumer and the industry has given us some space to pressure test some of those things and get them out in the market and get feedback. And so I'm excited about that, about having the leeway that I probably don't think we had 4 or 5 years ago to do this. And then have a conversation about it. Why is this the way it is? It's because we're solving this problem and people appreciate it. So I'm really excited about that. And what that means is, and I'll keep harping on this, it means we can start doing things now. We don't need to wait. There are things we can do that you can scale that do help make this problem way better. And it is measurable. And we can get it done. And then the other piece of the willingness is on the industry side. I've never seen such openness on the chemical and polymer side in this industry to attack this problem and to get outside comfort zones of existing product and existing polymer classes. The conversation's wide open and the investment money is there. Mm-hmm. So framing the challenge that you want to overcome and really being clear on what you want to do with it. The openness to innovate downstream is better than ever. And that's the most exciting part of my job on a daily basis. That's why we have a pre-textiles team. It's because we're trying to pioneer new space every day, because that willingness is there that wasn't there before. So that's what gets us excited for sure.
And importantly, the investment, the money to set up the lab, to put that money into R&D. I'd like to invite Barbara Martinez to join the panel now. Barbara is the Open Innovation Director at Conservation X Labs, and she's able to contribute on the Q&A side where the Microfiber Innovation Challenge is concerned. So if anyone has a specific question about the challenge or about their application, the deadline for the challenge is the 25th of June. So this is your chance to ask direct questions. I'll just make sure that Barbara's been able to join there. Hi, Barbara.
Hi, Brooke. Thank
Hi.
you for having me. And to all of you panelists, too, this has been a fascinating discussion, as well as I've been watching the questions coming in through the Q&A and the chat. And I guess I just want to reiterate something that has been said a few times, is that, we run these competitions not because we expect that there is one single silver bullet solution. A challenge model invites multiple solutions to a particular problem. So we're expecting to see all sorts of innovations come through this competition, and we welcome them. And the reviewers, they're the ones who are going to weigh the costs and benefits, the pros and cons of, for example, what is better to support, something that biodegrades versus something that's durable. You know, the point here is to look for solutions to the fiber shedding problem, and specifically those fibers that are long-lasting in the environment. So we do ask applicants in the application, if you're going to make a claim about biodegradability or compostability, you need to be specific. How is it biodegradable? Under what standards, what conditions? You need to specify that in your application. It's really exciting because these types of competitions, these challenges too, bring up all of these hard questions. And, you know, are we greenwashing? Are we getting into this greenwashing space? And can we approach these solutions or these problems in more of a pre-competitive space? These are all really exciting discussions, and I'm not going to claim to have the answers to them, but it's really nice to see this discussion in the QA here, and to get the responses from panelists as well. Mm-hmm. And yes, I'm here to answer any specific questions about the competition, the application that you may have.
I'm keeping an eye on the Q&A, and there's been a really lively Q&A going on. There's within the Q&A box a lot of answered questions already. Thank you to the panelists and to Neil for jumping in and answering some of those. And there are a couple that have just been submitted, one of which I'd like to put to the panel, maybe to Kyle initially. This is a sort of a big question, but I think reflects some of the confusion out there. What do you think, or which do you think is better, a biodegradable material or a durable material that has low fiber shedding?
Maybe obvious answer. I don't think that one is better than the other. I think, first of all, it's situational. You know, what are you trying to create? What's the benefit to the consumer that you're trying to provide? I'm not convinced that those things all can't work together as well down the road. So, as we said before, there's not a silver bullet. I think those things will exist together, and those things will exist separate, and they're both positive. Mm-hmm. You know, in terms of reduction of shedding versus biodegradability. To add a third one, maybe one day we want to shed on purpose because we can shed something positive. Don't know. It's certainly plausible. So, you know, it's really looking at you know, how we deploy these situationally and how we communicate that to the consumer. Mm-hmm.
Did any of the other panelists want to add anything on that one?
Yeah, I can, Brooke, if you want.
Yes, so please. Yes.
I'm a great believer in kind of going back and reading cradle to cradle every now and again when you're kind of struggling to answer some of these questions. There's so much in that book, but it didn't propose an either or. I think it appreciated the fact that Mother Nature is our most powerful circular economy, and everything in the universe returns toward, you know, heads back out of order into chaos sooner or later anyway. It's just a question of time. So our kind of human-made concept of kind of persistence or resilience is really, we're talking months, years, or decades, right? And we've created plastic to last for, you know, hundreds of years, and that's the problem. So how do we reverse engineer that to get it back into our most powerful circular economy? But in its useful life, you know, we should allow for in use, we should allow for reuse, we should allow for recycling, and then it goes on to become something else. But because either all systems leak or things wind up back in nature sooner or later, we should then have both of those as our kind of our design lens. So I think you know, Barbara's point around coaching anyone who's submitting ideas to back off any claims they're making against proven standards with, you know, rigorous pass-fail criteria, but don't settle for one or the other. You know, we're not going to solve this problem by putting all our eggs in one basket versus the other. We've got to bring both together. That's how we get to solve this problem.
Thank you, Neil. I want to come to the next question now. We've only got around 6 minutes left. It's a question about the way that we handle this as an industry. Microfiber pollution is a huge problem that requires all brands and suppliers to hold hands, big and small. this should be approached as pre-competitive and open source. Having a consortium that requires thousands of dollars to access those learnings isn't ideal. So any thoughts? Maybe Sydney, if you could shed some light on this and how you're working. You're working at a nonprofit providing information in this area. So maybe talk us through your views.
Sure. Yeah. So, definitely, the mission of MII is to bring all the stakeholders of the industry together to collaborate, right? Like has been mentioned by all of the panelists today, that we're not going to solve this problem in a vacuum. We need to work together. And part of that is, education, right? Honestly, a lot of people don't really understand what their clothes are made out of. And that might be part of the problem why we don't have as much push from consumers adopting greener solutions. They might not know that their t-shirt is made of the same material as a water bottle, right? There's a visceral reaction right now to people with like single-use plastic water bottles, but not the same visceral reaction to a polyester t-shirt. And, I think there is a little bit of education that can come into this for people just to understand where their materials come from. What are the pros and cons? They're not all evil, there are good things, and make sure that it's, there's an understanding. But then to provide kind of these resources, we provide open access resources, consulting, anything we can do to kind of help make change in this space as a nonprofit. So that is where we take the approach, is that there should be no barriers. It should be able to have people, even early stage research scientists that I work with, that just have an idea, right? They don't have money, they don't have funding, and we try to help them get to the space where they can start making an impact and making a change. So that's where we come in.
And maybe Kyle, your thoughts on that, because you've expressed many times through the discussions that you want to collaborate even with your biggest rivals, in the sportswear space. What would you like to see happen in this area?
I'd love to see outreach. I don't know the channels of communication, but we're open. And if we get a phone call or an email, we're responding. And we want to work with other people. We don't know what we don't know. We have our own challenges. We don't have the same challenges as other people. And we need solutions that are, relatively universal, so they're easy to adopt and they're affordable. So no disagreement from me on the comment from the person who submitted the question. This needs to be accessible. And hopefully we've showed that we're willing to share. So.
I'm just going to check we've had a few questions come through or statements on PHAs. Neil, there was a great sort of question and answer section that you've addressed, but it might be useful for all the audience to hear your input on PHAs and analysis in ocean water and the potential of a new yarn method that's come out of Leeds, or a methodology for validation.
Yeah, I saw the Leeds update just there. I'm not familiar, but it certainly looks exciting. On PHA, there's quite a few big players who have raised a lot of capital recently and gone, public through IPOs with big SPACs at multi-hundred million valuations. So that is exciting, because these businesses are now attracting the type of capital that allows them to go from 5,000 ton production maybe up to 20,000 ton production. So that's good news. The point around ocean biodegradation for PHAs is that the oceanic environment is tricky. Just coming back to Kyle's point around turning off the taps again, when we were looking at how can we understand this problem and solve this problem, 80% of all ocean plastic comes from land. So we were kind of looking at the terrestrial environment and creating a standard there that would more effectively biodegrade the materials before it ever got into a river and ever got into an ocean. That was kind of our theory of change. But because there's quite a, let's just say, media focus on the oceans per se, some of the PHA technologies have made claims that they will biodegrade in the oceans. So from a marketing perspective, obviously that's great. The problem is there's a very big difference between sinking to the bottom of the ocean, where it's effectively mummified. Nothing biodegrades down there at the bottom. It's like landfill. It's completely sterile. Being stuck in a gyre 10 to 15 feet below the surface with all kinds of variables is very hard to replicate in a standard, so hard to prove or disprove. Then you have the situation where it could float on top and then wind up on a beach, where a technology like ours, would be effective. So because there's such wide variability between those different oceanic conditions, making a broad claim that it biodegrades in oceans is something that, you know, some of the PHA players have been caught out on, and it's unfortunate because their technology is good and the world does need it.
I think that's an excellent cautionary tale, because it reminds us that we cannot be relaxed in the way that we present things as they are right now. And I think for any innovators out there who are considering applying for the challenge, keeping in mind what's been proven and what's able to be demonstrated versus what's claimed perhaps in the media, I think is a very useful reminder. We're out of time, sadly, because this discussion has been fascinating. Thank you very much to all of the panelists, Sydney Gladman, Neil Dunn, Kyle Blakely, and Barbara Martinez. If anyone has any follow-up questions, please send them through to hello@textyler.fashion or through the Conservation X Labs website, where you can apply for the Microfiber Innovation Challenge. For now, I'd like to sign off with just a final thank you very much to all of the panelists. Thank you.
Thanks, everybody.
Thanks, everybody.
you.
Thank you, Brooke.
Thanks for your input.
Thank you.
Thanks, Barbara.
Thanks.
Bye-bye.
Thanks, everyone.